Hi, I'm Billy Beck, Extension Forestry Specialist with Iowa State University Extension and Outreach, and Assistant Professor in the Department of Natural Resource Ecology and Management at Iowa State University. Today we're out at the beautiful Smeltzer Farm, which is a part of the Iowa Learning Farms. We're going to highlight a study today that's fairly unique in the region, looking at a potentially free in-stream conservation practice that deals with water quality and also wood and biology. Here in Iowa, in terms of sediment nutrient loading, we have a pretty good grasp on the performance of our edge-of-field practices and in-field practices as far as attenuating nutrients and sediment. However, we really don't have a good grasp on the channel itself. And the channel, according to the literature more and more, has an incredibly important role in attenuating nutrients and sediment and impacting our annual watershed sediment and nutrient loads. But in Iowa, because of a range of reasons that you can see some of these behind me, we've lost the functionality of the channel to perform a lot of those nutrient and sediment removal processes. We've straightened our streams, we've removed riparian vegetation along our waterways, we've removed in-channel wood, we've added artificial drainage to the landscape. So all of these factors, which we'll be touching on today, have really reduced the ability of the channel to play a significant role in attenuating nutrients and sediment, and in fact has maybe moved the channel to an important source of nutrients and sediments exiting our watersheds. So today we're going to be kind of exploring what if a free conservation practice that is kind of contentious may have an impact, a positive or negative impact, on our stream nutrient and sediment loads, and that being beaver dams. This study, funded by the Iowa Nutrient Research Center, is looking to do two main objectives. We really want to quantify the hydrologic impacts of beaver dams. So how do they affect flow? How do they affect water retention? How do they affect riparian groundwater table? Also, we want to see if we can quantify their impact on nutrients and sediment. Are they trapping nutrients and sediment? Are they providing opportunities for nitrogen removal, for example? So today here out at Smeltzer Farm, we're going to be doing a case study on one of our study dams in this beaver dam study and highlighting one of our grad students' very extensive efforts to answer these questions. And my grad student and I and our whole team here, we kind of do realize the challenges of promoting or keeping beaver dams in the landscape when you have an agricultural system and a highly modified system. And we're not really trying to promote dams or discourage dams. This study is really looking at, can we get some numbers on their performance and seeing what impact, if any, they're having on nutrients, sediment, and hydrology.
Hi there, we're at the Ann Smeltzer Charitable Trust Farm today. I'm Andrew Rupiper, graduate student in Dr. Billy Beck's lab. Today we're looking at a series of beaver dams. These beaver dams provide a number of services that we're going to explore further. One of the things I want to point out right away is just the stark difference in the stream channel above and below a beaver dam. We're going to see when we get to a larger beaver dam, the differences are much more pronounced. However, we really want to make sure we understand that these are going to be in a relationship between human use of the landscape as well as what the beavers are looking for. Beavers are producing these dams and pools simply as a way to stay safe and find food resources. Beavers were hunted almost to extinction in the state of Iowa in the early 1900s. Eventually they've recovered with some reintroduction efforts. Along the way we've ran into various conflicts, but we're focusing primarily today on how they impact the waterways, both the impaired waterways such as these channelized reaches, and we'll address some of the other waterways that beavers inhabit in the state.
One of the things we really wanted to emphasize about the system we're working in, and the system that's very common across Iowa, is this incised stream channel. And what I mean by incised is you can notice the extreme height difference between the top of the bank or the start of the floodplain and the channel bed itself. And that has a lot of implications for water quality and quantity. And a lot of our systems in Iowa are what we call disconnected. And what I mean by that is only the largest flow events in this kind of situation make it out onto the floodplain. As we know, when channels emerge out under their floodplain, a lot of good things happen for nutrient and sediment attenuation long term. So that's one thing we really need to think about, and Andrew's going to touch on a lot, is how do these dams operate in this incredibly incised system when a lot of the flow is being contained in that system, and we have an incredible stream power coming through these channels and their impacts on the dams themselves. So Really unique, and I think that's what's really novel about this study is this is a very, one of the first studies we believe that looks at beaver dams in this very unique altered system. And right here, just in general, there's a lot of great talking points that Andrew's gonna touch on right now.
Thanks, Billy. So yeah, like Billy said, there's a lot of research that's been done about what goes on behind beaver dams, but it generally takes place out west or up in Canada, places that we see these large traditional beaver meadows formed. We have this very unique landscape here in Iowa in that our channels are incised. A relatively small beaver dam, only 2 or 3 feet tall, can back up thousands of gallons of water, raising the stage of the stream so that other organisms like fishes, amphibians, you get deer and things moving through. A lot of birds of concern in the state of Iowa, shorebirds and the like, will utilize this as some habitat. The really cool thing is to come here in the summertime when everything's dry, it's a drought, all the streams are dried up, and you still have these massive pools of water, plants, all kinds of critters running around. One of the ways that we decide what stretches of river are dammed versus not, we'll look at things like biofilms on the surface, plants that are growing, algae if it's staying in place, mats of those types of organisms only exist in stretches of the river that are slowed by a beaver dam. The water that transits from one end to a beaver pool to the other moves much slower than water in the stream, either above or below that structure. Anytime you slow the water down, all of the natural processes have time to interact with the things that we're concerned about. Sediment gets deposited in place and it grades up, building the stream bed. Nutrients get processed by things like microbes and plants that are utilizing nitrate, phosphorus, and the like. Hopefully beavers can provide some relatively free, continually maintained structures to return some of those nutrients back to the landscape and keep them within the cycle, rather than sending them downstream to the Mississippi River, the Gulf eventually, and causing problems there. We're here at the primary dam at the Smeltzer Trust Farm. Beavers tend to build a primary dam and then some secondary dams to extend the pool as needed. This dam is providing a huge amount of ecosystem services, all free of charge. The dam itself is trapping significant amounts of sediment. We estimate somewhere in the range of 200,000 kilograms in this dam alone when compared to non-dam reaches. What does that mean? That's 20 dump truck loads roughly of this fine phosphorus-rich sediment that's being trapped behind the dam. The beavers are creating these large dams to provide them areas to move in and out of the system. They don't walk well over land, so they prefer to swim in the water. In areas like this, they've extended their dam all the way from bank to bank, creating a very wide channel in what's normally a very incised, very channelized waterway. They also utilize a number of materials when building their dam, not just sticks. They're eating the outside, the cambium of a log or stick to get the nutrients, and then they're left with this great building material. They place the large materials downstream to provide structure, and then they'll interweave a number of things into the dam to make a very dense, very non-porous structure. A lot of people think of dams as filters, when in reality, they're a very rigid structure that really only lets water over the top when rain events happen. Behind me, you'll see extending back into the willow trees, there are a number of interwoven dams with the bank. They've done that to extend that pool both laterally and up and downstream. We see evidence of a lot of the biological processes that we really hope to invoke here in the Iowa stream channels. We have all kinds of really effluent sediments churning up all these microbes that are denitrifying. We're trapping that sediment that we're concerned is eroding from the banks in our farm fields, locking it in place. This dam has been here for roughly 10 or 15 years. These aren't permanent structures in the state of Iowa. Our hydrology will remove them every now and then, but a lot of the legacy will stay in place. Those materials that were graded into the bed a lot of times will be integrated into the system, as well as all of the nitrate removal benefits that we've taken across the range of that dam's lifetime. Beaver dams are highly complex. They're made up of a lot of different materials found in the local landscape. Beavers will use things like grasses, sedges, root masses, integrate that in with a lot of the fine sediments that they're dredging up from the bottom of their pool, patting it in place each night to create a perfect watertight structure that they can exist behind. In addition, they'll start to use things like cobbles, boulders, rolling them up to the top of the dam to really anchor it in place. Every once in a while, we see beavers utilizing corn stalks. A lot of times that's just the proximity to the cornfield when the beavers are in the channel. They're going to use whatever's readily available. If you can put some distance between the beaver dam and your cornfield, you might not have that negative effect. Willows are the preferred food. If you see behind me here, we have all kinds of willows in this area. The Smeltzer Trust Farm has been intentional about leaving beaver dams in place. They like to see the natural action of the beavers, the plants, the trees, and everything working in concert. We get all kinds of little critters out here that are relatively rare, endangered in some cases, simply because these dams exist. They're providing all kinds of services just by their existence and trapping of the stream water. They're slowing the water. They're allowing all those processes to act upon the water and any sort of excess nutrients that might be bound within. They're also trapping significant amounts of sediment. We spend a lot of time and a lot of undergraduate hours training and teaching how to wander through these fine, highly effluent, delicious nitrate-reducing sediments. We've had about 30 different students out at our various sites learning things about water quality, hydrology, the ecosystem services that are provided. It's a really fun time to have them out with us. Being the trust farm, the Smeltzer area here is able to kind of experiment. That being said, there are a lot of opportunities across the state, especially up on the Des Moines lobe, where we have a really unique set of soil and water circumstances, relatively young landscape that could put beavers to work in potentially reducing some of the loss of that soil as well as processing nitrate. Even if you're not interested in those services, you have all kinds of animals that are going to show up at your beaver dam pool and share in the water resource, especially in that droughty summertime. Generally, when we're looking at reducing nitrate, we need three conditions to exist. We need low oxygen, which is provided in the base of a 5-foot, 6-foot deep beaver pool. We need organic matter. We need carbon. All kinds of it available here. We also need residence time. If those other two conditions are present, but the water is just moving through at a rapid rate, the water doesn't have time to interact with these processes. Putting a beaver dam in place slows the water, allows that carbon to condense and be saturated in an area of low oxygen, and those microbes just get to work. We see pretty significant reductions from above a chain of beaver dams to below the chain of beaver dams, simply taking small grab samples of water and analyzing them for nitrate conditions. We also see significant reductions in things like just mobile sediments, which generally are going to contain phosphorus in high quantities.
I hope you've seen today that these animals and the structures they create are incredibly fascinating and incredibly complex. And again, our goal of this study is to simply get numbers on their impact. We're not saying to encourage them or discourage them, but it is our hope to see that maybe when placed in the right spot on the agricultural enterprise, they could act more of an asset than a nuisance. If you'd like more information on this study, or if you've got dams on your property you'd like us to come out and monitor, please contact Andrew Rupiper, graduate student at Iowa State University. And with that, I'll just go back to my usually faculty MO, and I'll have Andrew get in the stream while I chill up here and get my lunch sandwich. So. Billy. What's going on? Sediment. Up with the truck.